everyone, it's my pleasure to introduce the paper. First, the outline of the representation. In this paper, we study the language phoneme multitask learning based on the APM network. It contains the shared feature encoder and the frame level phoneme classifier and the segment level language classifier. First, note AM-Softmax loss improves the AM-Softmax by adding the penalty on the angle directly. APM-Softmax will use the average maximum phoneme posterior probability in a chunk of T feature to indicate the degree of utterance level phoneme-aware. And it varies from training samples in every mini-batch. It should be noted that only the highest probability is used for indicating the recognition difficulty of phonemes. The figure shows that the additive phoneme-aware margin speed in 3 random selected batches with the control factor 10. It can be observed that each mini-batch, the number of noteworthy additive phoneme-aware margins are minor. The number of those peaks are similar among different batches, indicating that the training samples with highest probability are distributed evenly among the batches, which is significant for the iteration of training. OER datasets are used for both training and testing, based on THCH30 training data according to Cody recipe. A GMM-based ASR model is trained for the purpose of accurate phoneme alignment. We use the PDF IDs in each frame to represent the corresponding phoneme label. Here is the training details. The language phoneme multitask learning network is shown in system number 2. Compared with baseline network number 1, phonetic information significantly improves the language recognition performance in short arrows task and open-set task. In system number 3 and number 6, larger margins improves the performance in short arrows task and cross-channel task, while decrease that in open-set task. The results reinforce that the assumption dynamically setting the margin or angular margin according to the phonetic information for each training sample is more reasonable than using a fixed margin or angular margin shared by all training samples. In this paper, we have explored approaches to improve the language identification performance from 2 aspects. Thank you for watching.
Okay, thank you, Yanliu. Is there any question? So I have a question. You use phoneme-aware information to enhance the discriminative capability of language recognition. So the phoneme information is very useful, and other workers also show this result or similar result. So how to improve? I mean, what's the drawback of this work in how to improve in the future for the margin loss?
Our proposed loss function is based on the AAM-Softmax. We use the maximal probability, posterior probability of the phoneme classifier to add to the margin of the loss function to be the m plus beta multiply the posterior. And the margins will varies in training samples in every mini batches.
So the margin loss can be replaced by more powerful phoneme information or relay loss level.
Yes.
So in the future, we can try other other phoneme-related loss, including carrier divergence and other losses used by the speaker verification for the LID task. Okay. Any other question? You can type the question in the chat. Okay, I see the question. Can you compare the different ways of using phone information?
Sorry, I didn't hear the question clearly.
You can also see the checkbox. Can you see the checkbox in
I
question?
didn't.
Okay.
Oh,
I will read again. Can you compare the different ways of using phone information?
The different way is
such as in the future setter or in the margin. What's the margin?
we do some experiments on different margin and different weights of the posterior, and we found that when the margin is set to 0.2 and beta is set to 10, and it could achieve the best results on channel-wide condition and open circuit condition.
Okay. So any other question? If there are no other question, we can finish your talk. So thank you, Yan Liu.
Thank you.
Okay. Sorry, I can see other question for the former paper. So can I repeat this question for the above paper or the unsupervised polytrain models? Can also reply the question now? The Tsinghua University. Wang Jiang is there?
Okay.
Okay. I read the question. Firstly, we train an end-to-end multilingual VSR model. Then we train the end-to-end DID model with the encoder transfer learning from learning. Sorry, this is not for your paper. I can look at the next. Can domain mismatch be addressed by incorporating unable mismatch data during pre-training of representations? This question.
Okay. I think more diverse speech data would bring better results according to other experiments from other downstream tasks such as ASR. But we did not perform experiments for more data in the language recognition. And we would try more experiments in the future with more data.
Okay. I think many people may expect your result.
Okay.
The second question is from Dong Wang. Why pre-training can help improve the performance? And in essence, what was learned by pre-training?
Pre-training should learn the general representations of the speech including phonemes and speaker information, language information, or others, as the representation from the pre-training is used in many different downstream tasks. We think the pre-training contains enough information for the speech. So the representations are useful and effective to use to language recognition. That's my opinion.
So a problem is how to decompose the representation filter. You include language, speaker, or other information. So this is a problem.
Yes. It contains much irrelevant information. So according to different downstream tasks, we may design different architectures to classify. Yeah.
Okay, this is a solution. But for the cross channel, maybe it's still not enough. Okay, so this is an open question. Maybe we can communicate or discuss in the future.
Okay.
The final question is this method work on other tasks?
Yes. We just find that the unsupervised models work on other tasks, so we borrowed the unsupervised models to the language recognition. I have mentioned that, for example, the ASR.
Okay. So your work is very interesting. Many people can try this method in other tasks. Okay, thank you. So